Online design and simulation of the TDA38826 DC-DC Point-of-Load Regulator. TINA and TINACloud allow fast and accurate simulation and design of power management integrated circuits both offline and online. In this video, we will demonstrate the online design and simulation of the TDA38826 DC-DC Point-of-Load Regulator circuit using TINACloud. The datasheet of this device can be found on the Infineon website, and was used to create the SPICE model for TINA and TINACloud by DesignSoft. This model runs not only in TINA and TINACloud, but also in major SPICE programs including PSpice, CMetrics, LT-Spice, and more. Startup Transient Simulation. The startup transient of a DC-DC converter is the period of time during which the converter is transitioning from its off state to its steady-state operating condition. In most simulators, the startup transient simulation takes a long time, since the whole process from the initial state to steady state is simulated. However, due to the built-in average model in TINA and TINACloud, the simulation takes only seconds both online and offline. TINA and TINACloud can also be used to perform switching mode transient analysis. Due to the advanced multi-core solvers in both software, switching mode transient analysis is still quite fast, and results in more detailed waveforms. In addition, TINA and TINACloud include a very fast calculation of the ripple voltages, using the combination of the average and switching models. Let's load our circuit from the TINA examples folder. This circuit allows you to run all the necessary simulations for characterizing the TDA38826 from the same file, but separate circuit files for each simulation are also included in the folder. For running transient analysis, click the Transient Analysis Fast link. The time function of startup transient appears within a few seconds. Alternatively, you can also select transient from the analysis menu. Note that by default the Use Switching Model checkbox is not checked. This means that the fast average model is used. By pressing the Run button, the time function of startup transient appears within a few seconds. If you click on the top right of the startup diagram and run a cursor on it, you can check that the output voltage is 1 volt. Redesigning the circuit. TINA and TINACloud's design tool can determine circuit parameters to achieve a predefined target output. To use the design tool, select Redesign this circuit from the Tools menu, or double-click the text box next to the current circuit. The Design Tool dialog appears. So far the Vout voltage has been 1 volt. Let's redesign the circuit to generate a 3.3 volt output voltage. To do this, change Vout to 3.3 and press Run. The following screen appears. The design tool displayed a quick diagram of all the relevant analysis results, based on analytic calculations. As we can see, the design tool changed Vout into 3.3 volts and also the changed components are selected in red. If you click on the top left of the startup diagram and run a cursor on it, you can check that the output voltage is now indeed 3.3 volt. You can also run a more accurate numerical transient simulation on the redesigned circuit and see that it provides nearly the same result as the analytic result. If you run a cursor, you can check that the output voltage is now indeed 3.3 volt. Finally, you can also run the switching model if you click the Transient Analysis Accurate link or check the Use Switching Model checkbox at the Run Transient Analysis dialog. The calculation takes minutes, and the Vout voltage is very similar to the Vout curve provided by the average method. Let's select the output voltage. The only difference is in the ripple, which is not provided by the average model. If we zoom in, we can see the ripple voltage waveform more clearly. In addition, both TINA and TINACloud feature a fast and accurate method for the direct calculation of ripple voltages in steady state. Steady state analysis. Steady state analysis of a DC-DC power supply is the analysis of the circuit's behavior when it has reached a steady state. This means that the output voltage is constant, except for the ripple voltage, and all the components in the circuit are operating in their steady state conditions. TINA and TINACloud provide a very fast and accurate method for determining the ripple voltages in any circuit. They use built-in average models to quickly reach the steady state, and then switching models to determine the ripple voltage. This method allows a very fast determination of ripple voltages for any circuit settings, without the need of storing initial values of inductors and capacitors in the circuits. To demonstrate how this method works, we will use the same circuit. This circuit is identical with the previous circuit, except for some global parameter settings. The global parameter settings determine the starting time, 6 milliseconds of the switching mode transient analysis. We will use TINACloud to analyze the circuit and determine the ripple voltage. Let's run transient analysis. After a short calculation time, the ripple voltages and current of the outputs appear in a diagram. Similarly, you can also quickly simulate line stepping and load stepping circuit response. Line stepping analysis. Line stepping analysis of DC-DC converters is used to determine how a DC-DC converter responds to changes in the input voltage. TINA and TINACloud can simulate the circuit response extremely fast due to their built-in average models. To see how the circuit responds to a step change in the input voltage, click on the link, Line Step Analysis Fast. In a few seconds, the circuit response will appear in a diagram. You can also run the switching model if you check the Use Switching Model checkbox at the Run Transient Analysis dialog. The full ripple voltage appears. Load step analysis. Load step analysis of DC-DC converters is a type of circuit simulation that is used to determine how a DC-DC converter responds to changes in the load current. In TINA and TINACloud, you can also quickly simulate the circuit response to a load step. To see how the circuit responds to a step change in the I-step current, click on the link, Load Step Analysis Fast. In a few seconds, the circuit response will appear in a diagram. There is also a switching mode version to see the accurate simulation. Check the Use Switching Model checkbox in Transient dialog and run the simulation. AC analysis. The built-in average models of DC-DC converters in TINA and TINACloud allow fast and accurate AC analysis. Click the AC transfer characteristic link or select AC analysis from the analysis menu and run AC transfer. The AC Bode diagram of the loop gain appears. Efficiency analysis. TINA and TINACloud also allow fast and accurate calculation of efficiency as a function of load current. The efficiency as functions of time and load current is calculated using a special time-dependent I-out load current. Click the Efficiency Analysis Fast link or run Analysis Transient. Efficiency as a function of time. Click the TRXY plot tab. The efficiency as a function of output or load current appears. This concludes our presentation, showing the analysis of all important characteristics of the TDA38826 DC-DC Point-of-Load regulator. We have covered the following topics: startup transient, output voltage ripple, line step and load step analyses, AC analysis, efficiency. We hope that this information has been helpful. Thank you for your attention.
For more information, visit our website at TINACloud.com. Visit our YouTube channel, youtube.com/user/TINA Design Suite.